In this video, we are going to talk about first order differential equations, specifically the method of integration factors. In the previous video, we spoke about the method of separation of variables. Now, there are some of the differential equations that you cannot easily separate the variable, especially those that are in the form dy dx, then plus p of x y equals q of x. If a differential equation is in this form, it's difficult to separate the variable. So in this form, we look for the integration factor. Now, the integration factor is usually given by mu of x equals exponent integral of p of x dx. So when you use this integration factor, then you multiply it through by the differential equation, then we will be able to solve the differential equation. So let's take some examples and then look at how we can solve problems like that. Solve the differential equation dy dx minus y equals exponent 2x. So the first thing is to look for the integration factor. So we know that from theory, integration factor mu of x is equal to exponent integral of p of x dx. Now remember that we said the general formula is dy dx then plus p of x y equals q of x. So in this case, we can see that p of x is equal to minus 1. So the integration factor mu of x is equal to exponent integral of minus 1 dx. If you integrate minus 1 dx, you will get minus x. So this is equal to exponent minus x. So what we'll do is that, having gotten this integration factor, let's multiply through by the integration factor. So the differential equation becomes exponent minus x, then times dy dx, then minus y exponent minus x, and then equals exponent 2x times exponent minus x. Now let's do something here. What is d dx of exponent minus xy? Keep exponent minus x constant and differentiate y, so it becomes exponent minus x dy dx. And then you keep you keep y constant, then you differentiate exponent minus x. If you differentiate exponent minus x, you get minus exponent minus x, then y. Now you can see that all of this is this equation. So what it means is that we can replace all of this by d dx of exponent minus xy. So the differential equation becomes d dx, then into bracket exponent minus xy equals, now if you evaluate this, you can see that exponent 2x times exponent minus x is equal to exponent 2x minus x, which becomes exponent x. So this is equal to exponent x. Now this becomes d exponent minus xy. We are multiplying through by dx, so it becomes exponent x dx. So we can integrate now. Exponent d of exponent minus xy equals integral of exponent x dx. So actually here was an integral. Now you can see that here's integral of a differential. That takes us back to the fundamental theorem of calculus. I have already done a video on it. I'll link it in the description. So integral of the differential of exponent minus xy is equal to exponent minus xy equals, if you integrate exponent x, is the same as exponent x plus the constant of integration c. So let's make y the subject. So y is equal to exponent x divided by exponent minus x plus c divided by exponent minus x. So you see that y is equal to exponent minus 2x then plus c exponent x. Sorry, there's a mistake here. So it's rather y equals exponent 2x plus c exponent x. So solve y prime plus y equals sine into bracket exponent x. So let's rewrite the equation. That becomes dy dx plus y is equal to sine exponent x. So now we know from here that p of x is equal to 1 because p of x is a coefficient of y. So let's find the integration factor. Mu of x is equal to exponent integral of p of x dx. So this is equal to exponent integral of 1 times dx is the same as dx. And therefore, mu of x is equal to exponent x. So we multiply through. So this becomes exponent x, then times dy dx, then plus exponent x times y equals exponent x, then times sine into bracket exponent x. So what we'll do is that, what is d dx of exponent x times y? You see that the first thing is maintain exponent x, differentiate y, you get dy dx. And then maintain y, so plus, and differentiate exponent x. If you differentiate exponent x, you get exponent x, then y. Now you can see that here is exponent x dy dx plus exponent xy. It is exactly all of this. So that means that all of this equation can be replaced by d dx of exponent xy. So we now have d dx of exponent x y is equal to exponent x, then sine into bracket exponent x. So let's multiply through by d dx. So we have d, then exponent x y equals exponent x sine into bracket exponent x dx. So we can go ahead and integrate. So integral of d of into bracket exponent x y is equal to integral of exponent x sine into bracket exponent x, then dx. So if you integrate this, here becomes exponent xy equals integral of exponent x sine into bracket exponent x dx. Now, this integral cannot easily be done, so we need to use integration by parts. So what we do is that let's let I to be equal to integral of exponent x sine into bracket exponent x dx. So now let's let u to be equal to exponent x. Du in this case is equal to exponent x. And let's let div to be equal to sine exponent x dx. So if you integrate sine exponent x dx, you first integrate what is inside. So v is equal to, now if you integrate sine into bracket exponent x dx, you will get 1 over exponent x, minus 1 over exponent x, then cos into bracket exponent x. So using integration by parts, we know that integral of u div is equal to u v minus integral of v du. So this is equal to, our u was exponent x, then v is times minus 1 over exponent x cos into bracket exponent x, then minus integral of v, which is minus 1 over exponent x cos into bracket exponent x times du, and then du is exponent x. So this is equal to, this exponent x and this one will cancel, this one too and this one will cancel. So we are left with minus cos into bracket exponent x, then this minus and minus will make here plus, plus integral of cos into bracket exponent x dx. So here's exponent x dx. Now, so this becomes minus cos to bracket exponent x. Then if you integrate cos exponent x, you get plus 1 over exponent x sine into bracket exponent x plus the constant of integration, c. So it implies that e exponent xy is equal to, remember that all of this integral is equal to this. So this is equal to minus cos exponent x, then plus 1 over exponent x sine to bracket exponent x plus c. So let's divide through by exponent x. So y is equal to minus cos exponent x divided by exponent x, then plus 1 over, here becomes exponent 2x, then sine to bracket exponent x plus c divided by exponent x. So y is equal to minus exponent minus x cos into bracket exponent x, then plus exponent minus 2x sine into bracket exponent x plus c exponent minus x. So if we rearrange, we find out that y is equal to exponent minus 2x sine into bracket exponent x, then minus exponent minus x cos into bracket exponent x, then plus c exponent minus x. Solve the initial value problem. X dy dx minus y is equal to x. The boundary condition is y of 1 is equal to 2. So the first thing is to make the coefficient of dy dx 1. So we do so by dividing through by x. So dy dx then minus 1 over xy is equal to 1. Now let's find p of x. P of x is the coefficient of y, and in this case is minus 1 over x. So the integration factor mu of x is equal to exponent integral of p of x dx. So this is equal to exponent integral of minus 1 over x dx. So this is equal to, now if you integrate 1 over x, it's natural log of the absolute value of x. So this becomes exponent minus natural log of the absolute value of x. So let's multiply the equation by the integration factor. So it becomes exponent minus natural log of the absolute value of x, then dy dx, then minus 1 over x y exponent minus natural log of the absolute value of x equals exponent minus natural log of the absolute value of x. Now let's find d dx of exponent minus natural log of the absolute value of xy. What is this? Now maintain exponent minus natural log of the absolute value of x and differentiate y, you get dy dx, and then maintain y, so and then you differentiate exponent minus natural log of x. So you first differentiate what is inside. If you differentiate natural log of x, you are going to get 1. So here becomes minus 1, and then divided by whatever is inside, divided by x, then you maintain it, so exponent minus natural log of absolute value of x, and then y. So you see that all of this is what is here. That means we can replace all of this with d dx of exponent minus natural log of the absolute value of xy. So the equation becomes d dx of exponent minus natural log of the absolute value of xy equals exponent minus natural log of the absolute value of x. So if we multiply through by dx, it becomes d of exponent minus natural log of the absolute value of xy equals exponent minus natural log of the absolute value of x dx. So integral of the derivative of exponent minus natural log of the absolute value of xy is equal to integral of exponent minus natural log of the absolute value of x dx. Now exponent natural log of x is the same as x. So exponent minus natural log of x is equal to exponent natural log of x exponent minus 1, which is equal to x exponent minus 1. But x exponent minus 1 is the same as 1 over x. So it implies that all of this will evaluate to 1 over x. So 1 over x y is equal to, if you integrate all of this, you are going to get integral of 1 over x dx. Sorry, if you evaluate this one too, it's going to be integral of 1 over x dx. So 1 over xy is equal to integral of 1 over x dx. So 1 over xy is equal to, if you integrate 1 over x, you get natural log of the absolute value of x plus the integration constant. So it implies that y is equal to x natural log of the absolute value of x plus cx. However, we're given the boundary conditions. Y of 1 is equal to 2. It means that wherever we see x, we need to replace it with 1. So y is equal to 1 times the natural log of 1 plus c times 1 is c, and this is equal to 2. So the natural log of 1 is 0, so it implies that c is equal to 2. And therefore, the equation becomes y equals x natural log of the absolute value of x plus 2x. We are supposed to solve into bracket x squared plus 1, then dy dx plus xy equals 0. So the first thing is that we need to make the coefficient of dy dx 1. So dy dx plus x divided by x squared plus 1, y is equal to 0. Now p of x in this case is equal to x over x squared plus 1. So u of x, mu of x, which is the integration factor, is equal to exponent integral of x over x squared plus 1 dx. Now you see that when you differentiate x squared plus 1, you will get 2x. So what it means is that we need to make this numerator 2. So this is equal to exponent 1 over 2 integral of 2x divided by x squared plus 1 dx, so that these two can cancel this 2 and we'll go back to the original equation. So this is equal to exponent half of the natural log of the absolute value of x squared plus 1. I already have a video where I've shown how to do this kind of integrals. I'll link it in the description. So we need to multiply through by the integration factor. So we have exponent half of natural log of the absolute value of x squared plus 1 dy dx, then plus x over x squared plus 1 y exponent half of natural log of the absolute value of x squared plus 1 is equal to 0. So we can rewrite this as exponent natural log of the absolute value of x squared plus 1 exponent 1 over 2, and then dy dx, and then plus x over x squared plus 1 y exponent natural log of the absolute value of x squared plus 1 exponent half is equal to 0. So let's find d dx of exponent natural log of absolute value of x squared plus 1 exponent half y. So you see that this is differentiate y and keep this constant. That will be exponent natural log of the absolute value of x squared plus 1 exponent half, then dy dx, and then you keep y constant and you differentiate this. Now, so you first differentiate what's inside the bracket, you get, so this is plus 2x, then you differentiate the whole thing, but then you need to multiply it by 1 over 2 divided by x squared plus 1 y. So if Then you repeat it again. So exponent natural log of the absolute value of x squared plus 1, exponent 1 over 2. So this is equal to exponent natural log of the absolute value of x squared plus 1, exponent half dy dx. Then this 2 and this 2 will cancel. So plus x over x squared plus 1 y, exponent natural log of the absolute value of x squared plus 1, exponent half. So you see that all of this is what we got. And therefore, we can replace all of this by d dx of exponent natural log of. Now we can remove the absolute value and just write x squared plus 1, because for all values of x, this will never produce a negative number or a 0. X will always be greater than 0. Y equals 0. So if we continue from here, we see that d of exponent the natural log of x squared plus 1 y is equal to 0. So if we integrate both sides, we are integrating the derivative of exponent natural log of x squared plus 1. And then that is equal to integral of 0. So you see that this is exponent natural log. Sorry, there is a y here. Natural log of x squared plus 1 y equals a constant, because if you integrate 0, you get a constant. So y, but we know that exponent natural log of x is equal to x. So this becomes x squared plus 1 y is equal to c. So y is equal to c over x squared plus 1. So solve y prime minus xy equals x. Then the boundary condition is y of 0 is equal to 5. So let's rewrite this equation. dy dx and minus xy is equal to x. So p of x in this case is equal to minus x. Integration factor mu of x is equal to exponent integral of minus x dx. So this is equal to exponent minus half of x squared. So let's multiply through. So it becomes exponent minus half of x squared dy dx, then minus xy exponent minus half of x squared is equal to x exponent minus half of x squared. So all of this is the same as d dx of exponent minus half of x squared y. And this is equal to x exponent minus half of x squared. So the derivative of exponent minus half of x squared y is equal to x exponent minus half of x squared dx. This becomes integral of the derivative of exponent minus half of x squared y equals x exponent minus half of x squared, integral of that dx. So exponent minus half x squared y is equal to, if you integrate all of this, you will get minus exponent minus half of x squared plus the constant of integration c. So if we divide through, y is equal to minus exponent minus half of x squared divided by exponent minus half of x squared, then plus c divided by exponent minus half of x squared. So y is equal to minus 1 plus c exponent half x squared. However, we're given the boundary conditions. Y of 0 is equal to 5. So y of 0 is equal to minus 1, then plus wherever we see x, we need to put 0. So this is c times exponent 0, which is 1. So plus c is equal to 5. So this implies that c is equal to 5 plus 1, which is 6. and therefore y is equal to 6 exponent half x squared minus 1.